in this section, we are going to ask whether the demand function satisfies two basic properties. One is there a general way in which it responds to prices? In particular, is it the case that the law of demand holds? And the law of demand just basically says that the derivative of the demand function with respect to P is less or equal than 0 with inequality if x star is greater than 0. In other words, is it the case that as prices increase, demand becomes smaller as long as the consumer is not constrained? That's what that requires. And the answer is going to be that under the assumptions of our model, the law of demand holds. And I want to prove this to you, and I'm going to do it in two different ways. First, I'm going to do it graphically. That may be more intuitive for some of you. Remember that we have that the demand function may look like something like this. It's determined by the marginal benefit function. And we know that the marginal benefit function, as x goes down, is going to be increasing by the assumption on the second derivative. Now, suppose that you are at a point at any price P, let's say here. What happens as you increase the price? This is the initial price, let's say, to a price like this. Well, we know that the initial demand was going to be determined by this intersection, and that the new demand is going to be determined by this intersection. So, given the slope of the marginal benefit function, it has to be the case that as the prices go up, the demand is strictly going down. Now, what happens once we reach a price? Let me call that price P bar, at which it's a threshold price. At this price, the demand becomes 0 and stays 0 above it. Well, after this price, since the demand is constrained, further increases in the price cannot decrease the demand further. And that's why after that price, the derivative of the demand with respect to the price becomes 0. Now let me also give you a mathematical proof that will provide some additional intuition. Now, we know that for prices above P bar, x star of P is equal to 0. Since that is a constant function, it implies, it directly follows that its derivative with respect to price, as price increases, has to be 0. Now the interesting case is what happens in this range. In this range, we know that the demand function has to satisfy the following first order condition, which is B prima of x star of P has to be equal to P. That's the first order condition that characterizes the demand function. Now, let's take the derivative of this equation on both sides. And what do we get? We get B double prima evaluated, of course, at x star of P times the derivative by the chain rule of x star with respect to P equals 1. Now, this implies that the derivative of x star with respect to price is equal or is inversely proportional to 1 over this second derivative of the benefit function, but we know that this is negative. This is one of the assumptions of the model, and therefore the whole thing has to be negative. I like this mathematical proof because it really shows the connection between the second derivative of the benefit function and the law of demand. Now, another interesting basic question about the demand function is whether it is affected by the wealth of the consumer. Are consumers who have a lot of resources to spend in all other kinds of goods and services more likely to consume X at any price? in the world of our model, with these quasi-linear preferences, there are no income effects. What that means is that the derivative of the demand function with respect to wealth is equal to 0. And that is very easy to see why. The first order condition map basically has the marginal cost, which is the price. Remember, this is the marginal cost of buying X. And it has the marginal benefit function, wherever it is. But this marginal benefit function only depends on X. It doesn't depend on how much you are consuming of other goods and services by the quasi-linearity form of the preferences of the experience utility function that I'm going to write here just to remind you. It's just a reminder. Is given by this. Given that the marginal benefit function and the marginal cost of X are independent of M, and that the relative position of these two curves, as we have been seeing, determines the optimal solution, it has to be the case that the optimal solution, which is the demand curve, is independent of W. Now, the results that we have established are very stark and clean with these quasi-linear preferences, and they are approximately correct for a very large number of problems that we're going to study and that economists study. And basically the intuition that you should have is that as long as the X good is a very small fraction of the consumer budget, these are not bad approximations. However, I want to emphasize that when the preferences are non-quasi-linear, so with more general preferences that don't have this very stark additive separability form that we have seen, the law of demand can fail and the demand may exhibit income effects. It may depend on the wealth of the consumer. You should notice that goods that fail the law of demand, so a good for which dx star with respect to P is greater than 0, i.e. a good in which you buy more as the price goes up, is called a given good. And there is some debate among empirical economists about whether those goods are actually observing reality or not. But importantly, such goods cannot be ruled out theoretically. It's very easy to construct or preference functional forms of the experience utility function for which they show up.